An old folklore has it that there was a boy who was doing much about nothing. In a state of utter boredom, he was met by an older, perhaps wiser man who asked him what he was really doing. The younger boy said that he was killing time. The older man retorted, "You're not killing time, son. Time is killing you." This eerie sensation of more and more time being taken out of less and less that is remaining is a universal feeling. John Clare, one of the greatest nature poets of his time, in his imperishable poem Remembrances said that words were poor receipts for what time had stolen away. Time and tide wait for none is another of those expressions that have been used so much so that the gravity it carries sounds almost feeble. The theme of time is one of the most pressing ones in songs of love and romance, where lovers long for the time when love had gripped them in the peak of its powers. George Ezra, a wonderful songwriter, says, "Time flies by in the yellow and green. Stick around and you'll know what I mean." Or take Billy Joe Armstrong for that matter, who said, "It's something unpredictable, but in the end it's right. I hope you had the time of your life." Time is our father figure, with whom we have the deepest cherishing for, and equally a certain dread of. If our eyes were tuned to seeing light waves of wavelength of around 2 millimeters instead of the light that we see normally, which has a wavelength of 300 to 700 nanometers, we could see the origins of the father figure of time in the sky. This is because our universe started off in a bang as an infinitely dense object that exploded in all directions. This scattered radiation in it everywhere, and that radiation exists at a temperature of 3 Kelvin. This is known as the cosmic microwave background radiation. A glimpse into the interstellar or the intergalactic space gives you the traces of Big Bang, an event out of whose womb time sprang into existence. The notion that time had a beginning is a difficult one to swallow. This is because time, since Newton, has been thought of to be an absolute entity, something that flows regardless of existence, something that is isolated, universal, immemorial. It took the sheer genius of Einstein to point out that time was inextricably linked with space, which in turn was affected by mass. This idea that time flows differently in different masses has some of the most interesting consequences. This means that the closer you are to a massive object, the slower time flies. If you spent an Earth decade here on a fragile blue planet, and a friend of yours born on an identical date spent an Earth decade on a planet that is, say, 1,000,000 times heavier than the Earth, your friend would hardly have aged at all. We don't need to travel into space to observe these effects. Take extremely sensitive clocks and measure time in the Himalayas of Nepal and contrast that with how time flies in the flatter regions of Nepal. You will see that time flies slow in the flatlands, which are closer to the center of the Earth. An equally surprising fact is that you don't even need to travel to Nepal to observe these effects. With such precise clocks, you'll see that time flies slowly in your feet than in your head. In other words, your heart is older than your loins. Not only does time behave so strangely due to the presence of mass, but it also behaves in an equally strange manner when an object is non-stationary. We have all heard of Einstein's famous twins paradox. Consider two identical twins, one of whom travels in space with a velocity close to that of the speed of light, and another twin who stays on the Earth. If they met after a few decades, the Earth-bound twin would have aged, while the spacefaring twin would hardly have aged at all. You don't really need interstellar travel to observe these effects. For a non-stationary person, time flies slower in comparison to a sedentary person. With sensitive clocks, we find that time flies slower for a runner or a pilot or a driver or anyone in motion compared to a stationary person. But we do not always have these notions of time. Long before pantheons such as Newton and Einstein changed our perspective of time, Aristotle proposed that time was a measurement of change. If nothing changed, there'd be no way we'd be able to discern time. In and around when Aristotle lived, there were no clocks or watches to record time. The only way to know the passage of time was to watch the changes in positions of astronomical objects, the passage of sun through the sky, or movement of stars. If such changes, coupled with getting old, being born, being dead, and everything in between suddenly ceased, there's no way we could measure time, or so argued Aristotle. For him, time was an imperative of change. In modern times, this imperative of change is often referred to as the thermodynamic arrow of time. To visualize the thermodynamic arrow of time, you could think of a glass perched at the edge of a table. Give it a slight push, it shatters. This is referred to as a movement from a state of order to disorder. Take a room, for example. Without any external intervention, even the most highly ordered room turns into something of a degenerate mess if not used for a few years, with the lack of order getting greater and greater with the passage of time, the room getting messier and messier. This is partly what gives us a perception of the flow of time in the forward direction. If you happen to see a movie clip where splinters of a glass arrange themselves perfectly at the edge of a table on its own, you would have this feeling that the movie is played backwards. This is because our psychological perception of time is deeply rooted with the thermodynamic arrow of time. As we move forwards to our inevitable death, which is a state of disorder, or maximum entropy as it's called, our minds record the various events or changes that have taken place, and we play them in our heads as memories, which gives us a sense of time flowing. But our memories are strange things. We remember days where time seemed to pass so effortlessly as we were in our zones, doing the things we loved so wholeheartedly that we didn't have a sense of time. There are also days when the clock just doesn't seem to move fast enough, dragging itself so sluggishly that boredom seems eternal. Take a human with a memory and make him survive the fall of a black hole. He could see the past, the present, and the future all at once. That is, he could see time. This is why a colleague of Stephen Hawking said that if he knew that he was dying of a terminal illness, he'd want to be gobbled by a black hole and see how time, whatever that may be, behaves. In more recent times, a bewildering new concept of time has emerged. That is, we don't even need time while describing the physics of the real world. We could simply describe things that we see in terms of events and the relationship of those events with each other. Reflecting upon this, Carlo Rovelli wrote so poignantly, and we'll leave it at that, when he said, "We are glimpsing something about the mystery of time. We can see the world without time. We can perceive with the mind's eye the profound structure of the world where time, as we know it, no longer exists. Like the fool on the hill who sees the earth turn when he sees the setting sun. And we begin to see that we are time. We are this space, this clearing opened by the traces of memory inside the connection between our neurons. We are memory. We are nostalgia. We are longing for a future that will not come. This clearing that is opened up this way by memory and by anticipation is time. A source of anguish sometimes, but in the end, a tremendous gift."